All right, we're going to do 13.2, theoretical probability of compound events. So just like last time, theoretical meaning before we actually do anything, right? Just what might happen. And then compound, remember, means that we're going to have two things together. We don't have any new vocab terms today because everything is what we've already talked about. So we're going to find a probability using a table first. And the reason we have to do this is because with theoreticals, we don't know what could happen. It's not like experimental, where we know this and this have happened. We need to figure out where and how many times this possibly could happen. So we're going to find the probability that Jacob is going to roll 2 fair dice, number cubes, fair meaning that they're balanced and they have the same number of numbers, to find the probability that the sum of the numbers he rolls is 8. So remember, sum is adding. So what I did is we made a table that looks similar to a multiplication chart, but we're going to add these together instead of multiply them. So we're just going to fill these boxes just like we did multiplication, but add them. So 1 plus 1, 2, and then 3, and then 3, right? 4, 5, 6, 7. So 2 plus 1, 3, and then 4, 5, 6, 7, 8, and so on. 3 plus 1, 4, 5, 6, 7, 8, 9. And again, if you're just confused, I'm just taking 3, adding it to 6. That's how I'm getting 9, just like a multiplication chart. So 4 plus 1, 5, and then 6, 7, 8, 9, 10. If you notice, they just keep getting up, right? Bigger, bigger, bigger. This would be 6, 7, 8, 9, 10, and 11. And then 7, 8, 9, 10, 11, 12. 6 plus 6, 12. We want to know what the sum, what's his probability when he rolls an 8. So we need to go find all of the 8s. So we have 1, 2, 3, 4, 5. We get 5 out of, and a total of, well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 6 by 6 is 36. This is the probability of rolling a sum of 8. So that's how we would use a table. Okay, so this problem down here asks, give an example of an event that is more likely than rolling a sum of 8. So look at our table. We're going to still use this table up here. What event is more likely? What's going to have a better probability than rolling an 8? Okay? And why don't you find that probability? Probability of what? It's still going to be out of 36. What has a better probability than rolling an 8? Okay, I'm going to leave that one. You need to answer that, and then it's going to be in your form as well. Okay, another way, instead of a table, we can use what's called a tree diagram to find our probability. Okay? So we have a deli that prepares sandwiches with one choice of bread. So just like when you go to Subway, you tell them what kind of bread you want. One kind of meat, just like Subway, and one type of cheese. Each combination is equally likely. They all have the equal chance of happening. We want to find the probability of choosing a sandwich at random and getting a turkey, Swiss, and wheat. So this is a compound event that has 3 things happening instead of just 2. Okay? So a tree diagram is going to look like what you would think a tree. So we're going to start, I always just going to start with the first one they give me with bread. So I'm going to go, top of my tree is going to be white bread. That's my first choice. Well, with white bread, I can then choose a type of meat, one type of meat. So I can have white bread with ham. I can have white bread with turkey. And I can have white bread with chicken. So see how those are my branches. Then I can choose, gotta pick a different color, hold on. Oh, let's pick that one. I can choose cheese, cheddar or Swiss. Well, with my white bread and ham, I can choose cheddar or I can choose Swiss. And I can do the same thing here, which makes my branches a little hard. Cheddar, Swiss, cheddar, Swiss. But you can see it kind of starts to look, we make like a tree. Got a little lopsided, but that's okay. So that's just with white bread. So we would then have to do it again with wheat bread. All right, so I'm gonna write wheat here. Now to shorten my tree so that maybe this doesn't happen, we can actually use letters. Now I'm not gonna use white and wheat because they're exactly the same. So I'm gonna write the words out, wheat, white. But with my wheat, I can choose, I can just do H, T, it's supposed to be a T, it's too connected, hold on. T and C, ham, turkey, cheddar. And then I can do my cheese, which I used red, I can just do cheddar, maybe I go like this, and Swiss. Cheddar, Swiss. Cheddar, Swiss. Now, what we can do with this is now we can find the probability, let me do it in purple because that's how I started it. You know me and my color coding, probability of turkey, Swiss, wheat. And it says and. So it's not one or the other. I need a Swiss wheat turkey sandwich. So here's my wheat, here's my turkey, here's my Swiss. So it's right here. It only happens one time. Okay? It only happens one time right there. So we have one out of. Now, the branches at the very bottom is how we find out how many possibilities. So I just count all the bottom ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a total of 12 different types of sandwiches I can have, and only one of them is wheat, Swiss, and turkey together. Okay? Now, the next one says, what's the probability of choosing a ham sandwich? So this is a little different because it doesn't matter what kind of bread we have, and it doesn't matter what kind of cheese we have. It's very open-ended. Probability of just ham. It's still out of 12. Our tree diagram doesn't change. It's still out of 12, but I need to find ham sandwiches. So I have a ham sandwich with cheddar and white bread, but I also have a ham sandwich with Swiss and white bread. And then over here, I have the same thing, but with wheat bread. So I have 1, 2, 3, 4 ham sandwiches, either with white bread or wheat bread, and cheddar and Swiss. Now we always have to reduce, so I'm going to divide this by 4. And we will get 1 over 3. And that's how we use a tree diagram. Okay. So things to remember. Simplify our probabilities. Oh, I'm going to use a different color now. It's a lot of eyes. Simplify the probabilities. And remember, our probability of an event is the number of times the event could occur over the total number of possibilities. That was a lot of eyes too. Okay, Nan is getting dressed. He considers 2 different shirts, there they are, collared and a t-shirt, 3 pairs of pants, khaki jean shorts, and 3 pairs of shoes. Sneakers, flip-flop, sandals. He chooses one of each of the articles at random. What is the probability that he will wear jeans but not sneakers? I would give, my hint to you is use a tree diagram. Okay, set up a tree diagram for this one. Start with your shirts, then make your pants branches, and then make your shoe branches. Okay, so use a tree diagram. That's my hint for you. And then we will talk about what the probability is. Okay, until next time.